Hi, good morning everyone. Let's get started with the next topic, which is on scheduling, performing and monitoring backups. Okay, so basically we'll see that which are the tools we use for scheduling, performing and monitoring the backups. So we have the DBA planning calendar, which is DB13. So using DB13 we can go to this particular DBA planning calendar and we can schedule which activities, how we want to take a backup. Okay, so that is about taking a backup, and we can use tools like BR backup, or we can use tools like BR for restoring BR restore, and for archiving BR archive tools. And there is a file called init.sit.sap where we define how the different parameters for backup. Okay, so let's go to the next slide where I'm talking about the different parameters which is related with the backup. Okay, so you can see these are the different parameters which is available for backup. Okay, now next thing is the profile init sit.sap. Okay, parameter is tape_size. Okay, here we can see that this is the correct parameter. Okay, so basically what is happening is this is for BR backup and BR restore. We are specifying the parameter tape_size. Okay, so physical tape size should be always more than the parameter tape_size. So that is one thing to take note of. Okay, now phases of a whole backup. Okay, save control file to disk. Next is basically there can be two types of backup. One is offline backup and another is online backup. Offline backup is basically taken whenever you are starting your initial restarts of the system or initial start of the application, whenever you are going live with an application. So you take a offline backup just to make sure that you are fully covered, and the online backups are normally done during a business hours or during a time when the system is running or during the normal business days. Okay, because we cannot bring down the system to take the backup. For offline, what is required is system has to be shut down. This database need to be shut down. Okay, so let's get started with the offline backup first. Offline, basically we start the database, retrieve file names of data and online redo log files from database, and retrieve names of control file from init.sit.or. Okay, so once we retrieve this information, we shut down the database. Backup tape header using init.sit.sap, init.sit.dba and init.sit.or. Backup the data files, backup online redo log files, backup the control files, start the database, and backup reorg.log, struct.log, detail.log and summary.log, and shut down the database. So basically these are the sequence of activities which is involved when we are doing an offline backup. For an online backup, what happens is that we save the control file to disk, retrieve file name of data and online redo log files from database, and retrieve names of control files from init.sit.or. Here you can see that one basic information is we need to get the names of data and online redo log files from database, and we need to retrieve the log control files from init.sit.or. Okay, next is backup header, that is init.sap, init.sit.dba, init.sit.or. So we take backup tape header, and for all table spaces to be backed up, begin table space backup mode, backup table space data file, and table space backup mode, and finally we backup saved control file and log file switch. Okay, so this is about the different type of backup, that is online backup and offline backup, when to take it, and basically telling scenario when to take the offline backup and when it is not possible to take an offline backup. Okay, next is logical verification of a database backup. So after the database is backed up to a tape, we need to make sure that the database is readable. You can verify it. Okay, so then physical verification of offline backup. Okay, then we have offline redo log, files, status and options. Okay, next is about the restore and recovery. Okay, when do we need to do a restore and recovery? Basically, in an Oracle database, there can be numerous errors. Could be because of the table drop, because of, say, we deleted accidentally one of the row, we deleted accidentally some program error comes and we need to perform a statement rollback. So basically these are statement errors. Then process errors such as termination of the connection between a work process and a server process. Pmon rolls back the open transaction and releases occupied resources. Then we have the instance errors such as when the background process fails. The next time an instance is started, a consistent status is restored by means of automatic instance recovery. Could be because of the user errors, that is, he accidentally drops the database using drop table command. Media errors such as the head crash or accidental deletion of a database file. Okay, here this is basically giving an introduction of, we have the control files, we have the offline redo log files, then database data files. So these data files are corrupted. Okay, then here you can see that logical sequence number. Basically this is the sequence number 10, full backup is taken at 10. Then we have then sequence number, that is LSN, that is 11, 12, 36, 37, 38. At LSN 38 this is crashed. So in an SAP system with Oracle database, most data files have status online. Okay, and read write, because if the data files are online, then only we will be able to write to them. Okay, and it should be read write. For a functioning consistent database, all data files as well as the control file must therefore be synchronous, that is, they must match in terms of time. Okay, so Oracle creates synchronization data using timestamps. Timestamps are integral parts and they are integers that are increased during certain database actions and are entered in all data and control files, headers by the log writer or checkpointer process at the checkpoint. An example of a synchronization data is the log sequence number, which is increased by 1 during every log switch. At a more sophisticated level, Oracle can define synchronization on transaction level using the system change number, which is increased, for example, after the commit in a change transaction at the checkpoint. Okay, we just saw the scenario in the slide. Basically, at LSN 10 we have full backup. At LSN 38 a media error or user error damages the database so extensively that the database instance breaks down or database is inconsistent. The offline and redo log files that were created during the beginning of the backup and the occurrence of the error are available. So basically this is partial restore and complete recovery. Okay, so complete recovery up to lesson 38. So partial restore is taking place. Okay, so what happens because of a head crash, data has been lost during business operation. Now the database has become inconsistent and it will not run. So a partial restore and complete recovery is performed to get the database running properly again. To recover the database to its status just before the error occurred. During a restore, database files are copied from the backup media back to the disk. During a partial restore and complete recovery, only the required minimum of data is copied. Database files that are to be copied back can be combined from different backups because database files are no longer synchronous after a partial restore. The database is inconsistent and will not run properly after the copy back procedures are terminated. To synchronize the file, the database evaluates the synchronization data that has been saved in the file headers. The database requests all offline log files that have accumulated since the oldest database file in logical terms in uninterrupted sequence. During a recovery, all data changes logged by these offline log files are replicated in the files that have been copied back. With a partial restore and complete recovery, all changes are performed again until all data files are at the same SCN, a procedure called media recovery. Okay, the database is now in consistent phase, capable of running and back to the data state just before the error occurred. Okay, then database reset. Okay, so database reset, what is this? Basically, during an upgrade, extensive software or hardware problems have arisen. As a result, the upgrade must be terminated. Database is inconsistent and no longer running properly. Fortunately, a full offline backup was performed immediately before the upgrade. A database reset is performed to get the database running properly again. And to reset the database to its status immediately before the upgrade, database is reset using a full restore. So these are the scenarios when full restore is required. Okay, then point in time recovery. Basically, here we specify at what point of time we want to restore the data. That is at 5 o'clock or 5 p.m., 5 hour, 25 minutes, 38 seconds, we need to restore. So that is the point in time recovery. Okay, then database reset using a full offline backup. Okay, when you perform a database reset, the database is reset to its previous consistent status. Okay, database reset using a consistent online backup. Okay, then full restore and recovery process is defined here. Okay, so with a full restore and recovery, the database is reset to its consistent status between the point in time of the full backup and the current point in time. This function corresponds to the point in time recovery. Okay, now this is basically a scenario for full restore and recovery. Just go through this one. Okay, so that's it. That's what actually I wanted to cover in this particular training session. Thanks for joining and have a nice day.